Because the squared term coefficient is negative, the projectile vertex is its highest point.
Here in Hazel Growth Hollow, we can track the exact path of a red squirrel as it leaps through the air, while Kit, the Shiba Inu, watches from the brush. This leap is governed by the force of gravity. Because the squirrel is moving through the air, its height over time follows a curve that we can model with a quadratic function. Before we look at the equations, look at the physical action. The quantities we measure are built into the environment itself. By observing the squirrel's movement, we can see the forest as a living graph, where every jump leaves a mathematical trail we can record. On this carved wooden table, we've plotted the trajectory of a tossed acorn. The height is modeled by the function h of t equals negative 16t squared plus 64t plus 5. As the acorn reaches the top of its flight, it hits a turning point. In a quadratic model, this highest point is the vertex. The negative 16 attached to the squared term tells us the parabola opens downward. This confirms that the vertex we're looking at is the absolute maximum height the acorn reaches. Locating the algebraic vertex provides the coordinates for the peak of the motion, showing exactly how high the acorn traveled before starting its descent.
These tree rings act as a timeline. The axis of symmetry is the vertical line t equals 2. The vertex is the point 2, 69. Equal time intervals on either side have the same height. 1 second before 2 is matched by 1 second after 2 at 3 seconds.
On the way up, the acorn passes a specific height at t equals 1 second, exactly 1 second before the peak. By following the symmetry, we know it will reach that same height again 1 second after the peak, at t equals 3 seconds. We can use these mirrored time intervals to map the entire downward journey based on what we know about the climb. Look at this root system modeling a different launch.
The function is now h of t equals negative 16t squared plus 48t plus 7. To find the height at the very start of the motion, we look at the moment time is 0. When we substitute 0 into the function, the terms containing t disappear. Only the constant 7 remains. This value tells us the acorn was exactly 7 units above the ground at the instant it was launched.
The constant term c equals h of 0, so it gives the starting height.
We can see the entire system here in the hollow. The physical movement and the mathematical symbols are two ways of looking at the same event. Solve these problems by identifying how the physical peak, the mirrored heights, and the starting position align with the specific values in the quadratic formula. The environment shows the relationship through the motion of the squirrel and the acorn, and the algebraic notation provides the tool to calculate and predict that path. Look at the markers in the hollow. Which specific mark proves the mathematical relationship, and how does the animal's action make that math true?
At time 0, the height model equals 7, so 7 is the initial height.